All right, folks, we're going to be doing 6.6 rational exponents for Algebra 2. And so we're going to hop right into that. We have two new little, formulas for you guys here, or just simplifications, actually. So let's go a to the m divided by n. And this is going to be simplified to parentheses a to the 1 divided by n to the mth power. Fully simplified, this actually looks like the nth power of a to the m power. And then we also are going to look at, let's look right here, a to the negative m divided by n. This, as we know, any negative exponent is actually going to be 1 over a to the m divided by n. And what does this look like again? We have 1 over a to the 1 over n to the mth power. And so totally this looks like 1 over the nth root of a to the m power. All right, now that's a lot right there. So let's see this in practice. I think it's a little bit more clear if you actually see it in practice. So if I have, for example, 12 to the 2/3 power, we want to simplify this, convert the following from exponential form, this is called exponential form, to radical form. So, converting, well, this is m over n. So this is going to be the 3rd root of 12 squared. All right, now we could simplify that, but in this case, just to kind of show you we just want to convert it from exponential to radical form and don't need to simplify. So actually, we're just going to leave it there right now. For our second example, we are going to convert it from radical to exponential form and not simplify. So I'm giving you the example of 1 over the 4th root of 9 to the 3rd. Now, anytime we have 1 over something, we're going to actually need to do two things here. We're going to first need to simplify the denominator, and then we're going to need to put it back into a negative. This is dealing with our second formula I gave you over here. So let's look at this. First of all, we have 1 over, this is 9 to the 3 divided by 4. And because it's 1 over something, that means we can go backwards and say, well, this is actually 9 to the negative 3 over 4. And that is going to be our final simplification there. I'm actually going to box those two so you guys can see our final simplifications. I guess actually technically we're not simplifying them, but what our radical form would be up here and our exponential form would be down here. Now, our last thing that we're going to go over is just a review of the properties of rational exponents. So here's our properties of rational exponents. Our first property we want to go over is if we have a to the m times a to the n, this is going to be equal to a to the m plus n. All right, let's go over a second one. If we have a to the m to the nth power, we're going to multiply the exponents together. So this is a to the m times n. Let's go to another one. All of these are review, so I'm kind of going through them a little bit quicker than normal, but this should all be review right here. If we have AB, quantity to the mth power, we can break that up and say a to the m times b to the m. And it's the same thing. All right, our next one is a to the negative m. And we just talked about this up here and over here. So a to the negative m is actually the same thing as 1 over a to the m. And finally, if we have a fraction, a to the m over a to the n, this is going to be the same thing as if we subtract the exponents. So a to the m minus n. Let's look at examples of all of these. So over here, if we have x to the 1/2 times x to the 3/2, we are going to add the exponents, and that's going to be x to the 1/2 plus 3/2, which happens to be x squared. All right, our second one, let's go y. If we have y to the 5/2, and we're going to square that. So that is the same thing as saying, well, we're going to multiply the exponents together. Y to the 5/2 times 2, which is equal to y to the 5th. All right, our next one is going to be 16 times 4 raised to the 1/2 power. Now, anything raised to the 1/2 power, we also know that's the same thing as saying a square root of. So 16 to the 1/2 times 4 to the 1/2 is the same thing as saying root 16 times root 4. 4 times 2, which is 8. All right. 2 more here, guys. Let's go 25 to the negative 1/2 power. All right. Again, anything to the negative power, we worked with this up there. Anything to the negative power, we have 1 over 25 to the 1/2. This is the same thing as saying 1 over root 25, which root 25 exists, and that is 5. So 1/5 is our answer. Our last one here. Let's go 3 to the 5/2 divided by 3 to the 1/2. Well, we are going to be subtracting the exponents, so we have 3 to the 5/2 minus 1/2. This is the same as saying 3 to the 4/2, which is 3 squared, which is 9. Hopefully this helps you understand 6.6. If you are in my class currently, I would suggest doing the examples posted on Google Classroom. Otherwise, please contact me for examples. Have a great day.